Hi everyone, Miss Sloan here. Today we're going to be doing a quick little geometry review. I believe Miss Crump already sent this PowerPoint out to everyone, so you'll be able to go back and look at it to maybe check your work whenever you're completing an assignment or anything like that. So we'll go ahead and we will get started. Alrighty, I found this cute little picture on Google and I thought I should just share it because I'm so excited that I get to work with everyone again because I've missed all of my kiddos. Alrighty, so we'll do a quick check. To begin, we're going to be talking about symmetry. So if we remember, whenever I taught my lesson, we had stations where we practiced mastering our skill of symmetry. So stop here for a minute and just kind of think about what symmetry is. You can go ahead and pause the video and I'll give you just a couple seconds and then we'll talk about what symmetry is. So symmetry is when an object is made of exactly similar parts facing each other. So this is exactly what we did in our lessons that you did with both me and Miss Crump. Alright, so next we're going to practice lines of symmetry. I know we have lots of practice of this, but we're going to go ahead and practice just a little bit more. And I did some pictures that we're going to practice lines of symmetry on. Alright, so I got 6 different pictures here. So what I need everyone to do, or what I want everyone to do, is to pause and imagine that you can draw lines on the 6 different images that you see here and determine if they have any lines of symmetry, and if they do, how many lines do they have. So we can go ahead and pause just for a second, and then whenever you're ready, I will begin going over these one by one. All right, so the first one we're going to look at is going to be the star. Does the star have any lines of symmetry? What do we think? Yep, there's a line of symmetry. It goes right down the center of the star. And we know that this image is symmetrical because if we fold it in half, it's going to be the exact same thing. There's not going to be any overlap. All right, so what about the Batman symbol? Let's move right along to it. Yep, it's got a line of symmetry right there in the middle. Same thing, if we fold it, there's no overlap. Now we're going to go on to this picture of this beautiful building, and it has a line of symmetry. It goes right down the middle again, and you can see on each side it has the exact same things. Now let's move to this little image down here of this odd shape. Does that have any lines of symmetry? Is there any way that we can fold that so that parts do not overlap? Nope, we cannot do that. No matter how we fold, there's always going to be an overlapping part, so that's not a symmetrical image. All right, I accidentally already clicked the button on this, but we should have already talked about if this had any lines of symmetry in it. And so we have one right there. We have it right down the middle. And oh, there's another one. It goes down the opposite side, so it has both horizontal and vertical lines of symmetry. All right, now how about this picture of this little alligator? Does it have any lines? No, there's no way that we can fold it to make it look the same on each side. So we got all of our check marks and our nose to show us if we have them or not. Alrighty, so now let's talk about triangles. So I know we talked about a couple different types of triangles. So to begin, we're going to start with an isosceles triangle. Remember, an isosceles triangle has 2 sides of equal length. So we have a picture here so that everyone can see. And if I'm moving too fast, just remember you can pause this video and move at your own pace. All right, next we're going to talk about an equilateral triangle. An equilateral triangle has 3 sides that are equal. So we see here that each of the sides are the exact same length, and they even have the same angles inside of them. Last, we have a scalene triangle. So we have the scalene here, has our picture. And a scalene has 3 unequal sides. So we can see that no matter how we look, the sides of this triangle, they're not going to be the same. Alrighty, so now let's talk about angles a little bit. So if you remember, we talked about 3 different types of angles. So we have a right angle. We can know if a shape has a right angle because it has that perfect little square at the end. Remember, we were using our corner pieces of paper to check our angles. Then we have an acute angle. An acute angle is between 0 to 89 degrees. And then we have the obtuse, which is the large angle. and it's between 91 to 180 degrees. So remember in class we were using this corner of a piece of paper. We were putting that up to our shapes to see if it was either perfect, it fit perfectly in that square, and if it did, it was a right angle. If it was bigger than that piece, the shape that we were using, that means it was an acute, and if it had that overlap, that means it was an obtuse angle. So here are just some images that we can look at just to kind of get a visual of what each looks like. Alrighty, so now we're going to practice deciding whether or not angles are acute, right, or obtuse. So we'll go ahead and load all of these images on here. So again, go ahead and pause the video here and you can decide whether or not these 6 images are acute angles, right angles, or obtuse angles. And then on the next slide, we're going to go over what they are. So go ahead and pause. I'm going to go ahead and move along, but you make sure you pause your video and decide if they're acute, obtuse, or right. Alrighty, the first one, what do we think? It's 120 degrees, so that means it must be an obtuse angle. Moving right along, we have a 30-degree angle. Well, we know that acute is between 0 and 89, so that must mean that's an acute angle. Next, we have that perfect L. That must mean it's a right angle. Alrighty, 45 degrees. That's less than 90, so that must be an acute angle. Again, we have that perfect L shape, so that's going to be a right angle. And last but not least, we have this one is kind of tricky because it's oriented a different way, but we see that the measurement or the angle measurement is going to be 112, and that's more than 90, so then we should automatically know that that's an obtuse angle. Alrighty, so now to the tricky part, the additive angles. So we're going to go over a few examples and we're going to figure out how to find the missing angle. Alright, so to begin, this is very important. Whenever you're looking at an image and you're trying to decide how to read that angle, you're going to read it as the same way that I have listed the arrows here. So we have this angle right here. So we have the arrow following it down. So we start with A, we go down to B, and then to C. All right, so B is going to be the angle that we're looking at. So if we were going to write it, we are looking at angle B, which has that perfect L shape, so it's going to be 90 degrees. So we know that angle ABC is 90 degrees. Alrighty, so now we're going to do a quick little question, and remember, pause the video so you can go over the question yourself and see if you can figure it out. So let's see, if angle FJG, so we can go over here and we can draw it. So we're looking at FJG measures 90 degrees. We have that perfect square. How much does angle HJG? So we got H, J, and G. So if we know that angle FJG is 90 degrees, how can we solve for this missing angle here? Well, we know that a straight angle is equal to 180 degrees. So that means right here, all we have to do is subtract we need to subtract 90 from 180, and we are going to get our answer. So hopefully you pause the video and you solve this problem. But if we were to do that, we did 180 minus 90, it's going to be 90. So that's also a 90-degree angle. Alrighty, let's move right along. Alright, so what about this problem? It's kind of the same that we just did. So we know that the entire space here is going to equal 120 degrees. We know that angle A here is going to be 50 degrees. So what do? It's going to be the same thing we did last time, and we're going to subtract that 50 from 120. So after we do that subtraction problem, we come to find out that angle B is going to be 70 degrees. And you can always go back and check your work by adding the angles together to make sure they equal that total amount that we see. So if it was 70, we would add 50 to it, and we should get 120. And whenever you do that, that's exactly what you get. Alrighty. So we got the steps here so everyone can see. Remember, we can pause the video if we need to, if I'm moving too fast for everyone. So we solve it and we get the answer. All right, so this is going to be our last sample problem. So we see here, we have the outline of this figure, and the entire space of it is going to be 110 degrees. Well, we know that SRT, the angle for it, is going to be 27 degrees. So how do we find the angle for QRS? Well, it's going to be the same thing that we did. So I'm going to go ahead and tell everyone to pause the video and to see if you can figure out the right answer. All right, so for this, we're going to simply do the same thing that we've done before. We're going to get our total amount, so that's going to be 110, and we are going to subtract 27 from that number. Once we subtract it, we get a total of 83 degrees. So again, let's go ahead and double check ourselves. So this angle right here, QRS, is going to be 83 degrees. Let's add 27 to that to make sure we get the total 110. Yep, sure enough, after adding it, that's what we get. All right, guys, that is all I have for you today. So I hope you enjoyed it. If you have any questions, feel free to contact Miss Crump. I know she'd love to help you. And if you want to talk to me, I'm sure that we can set it up on our Monday or Friday afternoon calls that we do every week. So I hope you enjoyed watching this little video. I enjoyed making this PowerPoint for everyone, and I miss you all very much. Have a good week, guys. Bye.